Welcome to today's webinar with the title Digital PCB Standards Material Database. I am Andreas Schilp. I've been working for Würth Elektronik for almost 30 years and I'm also the speaker of the webinar today. These are the items of my agenda for today. So, first of all, I want to name my objectives for today's webinar. Secondly, I will talk about the database we've created for Altium Designer 20. And third point is we want to show you a demonstration video how to install the material library, how the process looks like. Then I will point out the differences between the material data which you can find in the descriptions, and point 5 we will talk about minimum copper layer thickness which you can find in the IPC standards, and last but not least the summary and outlook. So my two objectives for today's webinar are, firstly, I want to have that all of you know about the circuit board technology material database of Würth Elektronik and how it is structured and what material data content is included, how to load the material database and where you can get the data from. And secondly, each participant will be given a receipt for determining the minimum copper layer thickness permitted by IPC according to the information in the material database, or which you also could find in our standard layer stacks. So these are the two objectives for today. If you reach it, I'm fine. So now let's come to the material database, and this is a interesting, a nice feature in Altium Designer coming with revision 19 some time ago, but we were very curious about that new feature at that time already, and meanwhile we have been successfully installing this into our digital standards. So you can request the files in the box, in the red box here. There's a link behind which will be also active in the presentation, in the final presentation you will receive. The other possibility to get the files is to request that via our internet website. So last time, the last webinar, we talked about standard layer stacks. We are providing, for example, for basic technology, for HDI technology, as well as for rigid flex technology. So here are the links to download them directly from our internet website. So that's just to get the bridge to the last webinar. And today we will see how they are made. They are all based on this material database and done in Altium Designer 20. What are the benefit? What is benefit for using this material database? Firstly, and I think this is a new feature that's pretty important for you. It enables more control to the PCB designer as a plug-in solution. So you can just install it into your Altium Designer, and the database provides a lot of material data shows you options you may need in meeting your requirements in your project. It also shows the impact of what you are doing or respectively changing. So if you change a core or a prepreg, for example, you can see it. You can see it in real dimensional properties in the Altium 3D view, for example, and it helps to decide whether you have to make adjustments in the trace routing to meet impedance requirements. As you can see, there are only certain thicknesses available in cores and prepregs, so there's not any value available. So finally, you have to decide for a prepreg or a core and a copper thickness, and then you have to adapt or adjust your trace routing to meet impedance requirements. You can all see that in the EDA tool in Altium Designer. And on the other hand, it secures accurate material selection with DK/DF values, for example. So manufacturability should be okay if you make a stack up based on this material database. And if you use Altium Draftsman for your documentation of your fabrication data, Altium Draftsman also uses the material data of the library. So you have correct, accurate information in your documentation also. And the 3D field solver, which is integrated in Altium Designer, this is a Siberian program, is able to correctly calculate impedance values based on accurate material data. So that's more and more important. And last, but of course not least, the Würth Elektronik material library is a perfect match for our capabilities. So if you use the materials out of the material database, we have the material on stock. We can produce that. We know the processes, the flows, the yield is high, and so that's also a cost optimization if you use this data in the material database. How it is structured. First of all, we can see the gray box on the right bottom side. These are data, material data in the database coming from Altium with the Altium Designer. So there are, for example, solder surfaces inside, also cores, prepregs, which you may use. And on top of this Altium data, we have created several categories of material, for example, prepregs, cores, copper foils, solder masks, and coverlay bond plies, especially for layer stacks. You want to have for flex rigid or flex constructions. And all this is in the Altium Designer 20 material library included. For example, here we can see a prepreg, which is a little bit brighter compared to the core, which you can see here. It is a darker brown. Here we have all the copper layers in between, and on top and on bottom we have the solder mask. So this is a picture directly out of the Altium Designer layer stack viewer. So now I'm really interested in your answers. How often have you worked with the material database of your EDA tool so far? Have you used it regularly, or do you use it regularly, or have you tried it sometime? Did you never use it, but your EDA tool would have the chance to do, or provides a material database? Or fourth option, you don't have the possibility as your EDA tool does not support this. So I will start the poll now. I want to ask you to make your choice. in the new window, and we will wait a few seconds to get your answers. I've also done this poll in the German session, and it's not exactly the same here with you, but it's comparable, let's say. So it's an interesting situation and result. So we are around about 70%. I will wait a few more seconds, and then I will close the poll and show the results to you. Okay, so now I will close the poll and show the result, and maybe surprising, but just 16% are using material database regularly. 32% have tried it sometime. 38% never did it, but could do. So in the German session, that was more than 50% even. And 13% do not have the chance to use that option, as the EDA tool does not provide it. Okay, so thanks very much for your answers. It's very interesting. So now I want to make a comparison between the EDA stackup, so Altium Designer, how it shows the layer stack in the layer stack manager, and how it looks in the real life. So what you can see here are the different material categories. So here is solder mask, here we have copper, then next thing is a prepreg. So we have the normal way how to produce a multi-layer board with prepreg and copper foil to the outside. Then we have a core material here in the darker color, and again copper, then prepreg, again copper and core, so symmetrically build up. So normally it should look like this. So that's how we produce PCBs. So we start with cores, but the cores already have a copper cladding on both sides and with the same copper thickness. So that's important for the production. And we don't use single copper foils inside the PCB. We're always using multi-layer cores inside. So finally, that's how a 8-layer multi-layer is produced with prepreg and copper foil outside, 3 cores already cladded and edged with your cladded with copper and edged with your artwork. So there's a certain difference between how Altium Designer handles the materials and compared to how it is done in real life. Maybe this could be improved in a new revision of Altium Designer. That's still my hope at this point. So next thing is I want to show you a video how step by step the material library import is working into Altium Designer 20. I hope you can hear the sound also. Maybe you have to turn on your volume on the computer. So sometimes there are small problems with the sound of the video. So now I will start this.
Hello and welcome to this video tutorial. My name is Sven Ingelfinger. Today I want to show you how you can import a material library into your Altium Designer workspace. As you can see, I've already opened the PCB document, and from there it's very easy to navigate to the Layer Stack Manager. Just simply click on the Design menu bar at the top and open the Layer Stack Manager. The Layer Stack Manager is the place where all the layers are arranged in the PCB document, and it's also the place from where you can import an external material library. Just go to Tools and open the section Material Library. Then another window pops up where all default materials are included in the database. So you can choose from different foils, from cores and prepregs, and there are also demo data available from Altium itself, and you can modify them, choose them, and you can also load an external library from there. So click on the load button at the left corner and navigate to the downloaded files for your library and open them. After that, you see that all the materials from Würth Elektronik are now added to your material library. So you can see it in every section, in cores, in foils, and prepregs, that a lot of materials are now available. They are marked with VE as manufacturer. You also have a kind of shortcode that makes it a little bit easier to use, and also some other parameters like thickness, construction, reason, and so on. And you have different parameters for each category. There's also solder mask available, as you can see right here. By hitting the OK button, all the materials will be added to your library and are now available from your layer stack manager. So we will now select one. Selected the top layer right here, and in your properties panel on the left, there's a section material where you can now hit the 3 dots button, and from there you can use those materials which we have added before. And it depends on which kind of layer you have selected right here. The 3 dots navigate to the corresponding category in the material library. So when I hit the top layer, for example, only foils will be available. For this example, we will use something typical, like maybe this one here. It's 35 micrometers, and with OK, it's now in our layer stackup. As you can see, I've marked on the stack symmetry right here in the properties panel, and that's the reason why both materials, the top layer and also the bottom layer, are changed together. That's also very useful when you have a multi-layer board with 10 or more layers, something like that. And it's also possible to add another layer right here, some thickner layers, for example, and choose it right here. For example, something like this. As you can see, it's also kind of symmetrical and changed to the selected material. Sometimes you want to change the thickness units. It's possible via the menu Tools, Measurement Units, and you can now switch, for example, to micrometers, or for example to mil or something like that. There are also some layer stack visualizations available right here, where you can see the board in another perspective, for example in 3D mode, or show the full stack, or in real corresponding height, so that you get a better imagination of how your board is manufactured later, or how it's arranged. So what Würth Elektronik has created right here is very helpful in the daily work. As a designer, it's really complex sometimes when it comes to setting up a complete layer stack, maybe for complex boards especially, and it makes it a lot easier when you know the materials exactly from your manufacturer. So it's needless to say that all the communication effort you have in such a situation is a little bit simplified through this material library. Another thing I want to mention now is when you want to go back to your default settings from your material library, there's also a file available. Go to the Tools, Material Library again, and you can now load the clean lib file. It resets all the entries from your database. Just open it as you did it with the material library before, and now you can see all the material entries from the manufacturer are gone. Only the default settings are now in the material library. Maybe for some reason you need it. I only want to mention that. So thank you for watching. I hope this video was helpful for you, and I see you in the next tutorial. Bye bye.
I now have a quick installation guide how this performs. So that's more or less the same content as in the correct video. So what you can see here is the normal view if you start the Altium material library. So there are already some materials inside. What you can see here is the surface finish options, hot air solder leveling, electrolysis nickel immersion gold, OSP, and so on and so on. And so you should start Altium Designer 20, open your PCB or create a new PCB. Afterwards, you are in the PCB editor, then access the PCB layer stack manager, design layer stack manager, open the Altium design library, T&M, shortcuts. To install the Würth Elektronik material library, click the load button. The green frame shows where it is. So here is the load button. Then choose in the menu the material library XML file, open that, and loading is performed. So what's really important is to activate the columns description and node in the setting menu. So the setting menu looks like here with the wheel where you can activate the description and node. So afterwards it's done and it looks like this. So you can see this is now the user specific material data inside with a lot of data, and very important is the description. For example, you can see here which material quality is used, and we will show this in more detail in a second. So sometimes it's also useful to delete user content. So if you have, for example, have your own material data created in the Altium Designer, so you can also remove that. So there is a file called cleanlib.xml, and it comes with the Würth Elektronik circuit board technology material library already. So what you do not can is to what you do not could erase or delete is the Altium entries. They will stay. So just follow the quick installation guide and load the cleanlib.xml file. And after loading that, the user data will disappear and the Altium data will stay for further use. Okay, so the description makes a difference, and this is an example based on a rigid flex technology with 10 layers, so 6 layers on rigid material and inside a 4-layer flex package. And you can already see the descriptions and the notes showing, for example, the quality of the materials and kind of description for the materials. In the flex area, we can see, for example, the usage of polyimide as well as orientation. Now we want to go a little more deeper into the data content, and here we can see the cores. So all the cores are highlighted now, and we can see even the constructions. For example, a core with a thickness of 0.71 millimeters is made up out of 4 times prepreg 7628M. So there is a resin content. You can see also DK values, DF, DK, glass transition temps are user material data. So cover lay and bond ply especially This is the table with the options here. And next thing we want to see is prepregs, different prepregs as well. We can see the construction here. So there are different possibilities. You can have one 1080 prepreg at a time, or two, or even three 1080 prepreg at a time. So there are three different options, and with, of course, with different thicknesses. And the thicknesses are calculated after the lamination process, assuming 50% copper area from the layout on the copper side. So this is still a chance to improve the tool in Altium Designer. Maybe sometime they have the chance to rely on the artwork and calculate according to the artwork on the copper area, the thickness, so with a corrective factor, for example. So that's still a wish of mine. Next thing is we want to have a look at copper foils. And the first kind of copper foils, they are all in one category, material category, but the first thing we want to look at is plated base foil. So these are outer layers where we have a certain base foil, and there is a plating on that base foil. And now that's important. In the description, we can see what the starting weight of the foil is. So, for example, here is starting foil, a quarter ounce or half ounce, 1 ounce, 2 ounce, 3 ounce, and this will be important afterwards. I will show it. The next thing is a base copper. Here we have ED base copper and RA base copper, so electrode deposit copper, which is the standard copper, or rolled annealed copper, especially for flex and flex rigid PCBs. And here the weight and thickness relation is correct, but you should not rely on the weight data for the plated foils, as due to rounding they are not precise. So now it's time to have the second poll, and I'm really interested. What is your main motivation for using a material database? We have 5 different options. First is support in the creation of complex own stackups, not setups, stackups. Reduce the amount of coordination required with the PCB manufacturer. Usage of the 3D field solver in Altium Designer. There is a Siberian 3D field solver integrated. Fourth is adapting Würth Elektronik standard stackups to my specific requirements. And finally, everything other. Please explain in more detail in the question field if you like. So now we'll start the poll and ask you for your answer. So we've got around about 20%, so please make your choice. I'm really interested about your number one motivation. Of course, all of the 4 points are very interesting, of course, but of course you have to decide for one, for your top one, please. We've got 60% of the answers, 70%. So I will wait just a few more seconds, and then I will close the poll, which I will do now, and show the result. So 22% have their main motivation in doing their own complex stack-ups. Around about 50%, 51% to be precise, want to reduce the amount of coordination between PCB manufacturer, but please stay in contact with us. That's always a chance to improve things. 10% want to rely on the material data for the 3D field solver. 16% want to change our standard stackups for their specific requirements, and just 2% have other motivations. So maybe you will show us this in the question field. Okay, so thank you very much for your answers. We will now follow the presentation. And that's the next thing, how to get values for minimum copper layer thicknesses according to IPC. That's a really frequently asked question. How can I know what's the minimum copper in the final PCB? And we have to decide whether we are talking about inner layers or outer layers. So IPC has two different cases. For inner layers, they have the designation internal layer foil thickness after processing. And this is documented in specification IPC 6012 for rigid and HDI, and IPC 6013 for flex and flex rigid technology. And depending on the foil starting weight, which you can find in the column thickness of the base copper in our material database, so thickness is the point, and we have to consider that the copper foil which is supplied to us by the base material producer could also have a minimum tolerance. So we have to consider that already in the calculation. And during the processing of the material, in the processes there are some cleaning and etching processes, and this could also reduce the thickness. So that's the calculation for inner layers. For outer layers, it's comparable with one big difference. Of course, outer layers, they see a plating process. So plating process, we have to consider as well the tolerance of the copper base foil plus an average or minimum plating thickness, depending on IPC class and IPC type for flex and flex rigid. So for rigid and HDI boards, there is the average plating thickness, and for flex and flex rigid PCBs, we have to consider the minimum plating thickness. Again, minus the process tolerance reduction. So now we have a closer look at the tables. And the first example is an outer layer with a 1/4 ounce base copper, which means 9 micron copper foil. And this is the line we have to follow, 9 micron starting. So that could also be 7.7 micron delivered, plus average plating for class 1 and 2, or average plating for class 3, depending on your IPC class classification, and minus 1.5 micron for cleaning processes and etching processes. So finally ending up in a minimum surface conductor thickness. This is external, not internal. So outside outer layer, starting 9 micron, ending up in class 1 and 2 with 26.2 micron or 31.2 micron for class 3 application. So plated base foil, as we have named it in our material database. Now for inner layers, there is no plating, and this example shows a 1/2 ounce 70 micron starting foil again, tolerances and processing reduction, ending up in a value of 11.4 microns. So this is for rigid and HDI technology. For flex rigid, this is a little bit different, even more complex, depending on the type of the IPC type of the technology. So whether we have flex or flex multilayer or flex rigid, and again, depending on the thickness. So we have slightly different calculations, starting with the 9 micron foil minus tolerance plus minimum plating for type 4 in this case, as we are talking about rigid flex technology. And this is the minimum plating, as we talked already. So minimum plating, and depending on the thickness, up to 1.5 millimeter this column, and more than 1.5 millimeter this column. So finally, we are ending up in a minimum thickness according to micron. The minimum thickness is, according to IPC, 36.2 millimeters. Okay, so then it's time for a summary and outlook. Our digital material database is available for Altium Designer 20 already, but more EDA tools will follow. We will work on this topic as well, on the updating of all our standard stackups on our website. Last webinar, I talked about having it done already, but we are delayed, and I think it should come within the next 2 weeks. So you may see that immediately as the naming will change. The naming will include the revision 2.12 for the new revisions. Okay, so we are also still working on the rule sets for Altium Designer. We have made some progress. So in the year 2021, you will see also templates with rule sets. So if you think you would like to cooperate with us for other EDA tools, you are welcome. So please drop an email to me or write in the question box. And if you are interested in our circuit board technology webinars, register for our newsletter on our website. There will be a link in the presentation as well. So this brings us to the end of the presentation, and I want to thank you very much for your participation and your questions.